My name is Julian Garcia, and I am a senior lecturer. I am also the course director for the Bachelor of Computer Science and the Bachelor of Computer Science Advanced with honors. Computer science studies the process of computation, and computation is something that is everywhere. Computation means transforming information in a way that makes it useful to human beings. For example, before coming here, I took out my mobile phone, put in the address, and I was offered different routes to come here. So the process whereby those routes are calculated or computed and the algorithms behind it, that's the kind of stuff that is behind the subject matter of computer science. Since computation is everywhere, I mean, we literally carry around computers with us at all times, right? Typically we would have our mobile phone. So that means that the process of computation is actually everywhere. And because it is everywhere, there's a large demand for experts that understand how to create that technology. And I want to emphasize that aspect because when you come to study computer science at Monash, you don't come here to learn how to use technology. You come here to understand how to design the technology of the future. In each semester, you would typically take a number of units. Some of those units we call core units, and those are the foundational units to the discipline. And we also have a set of specialized units that together give you an in-depth knowledge of a certain specialty of computer science. We offer two specializations: advanced computer science, which focuses on algorithms and advanced programming techniques, and data science, which focuses on the particular challenges of working with big amounts of data. The specializations are just a way for you to focus a little bit on those aspects that you think you will enjoy the most in computer science. There's also some space for a number of elective units, and those units will give you the chance to go and do units in other faculties if you are interested in combining computer science with other areas of knowledge, and that's, I think, very powerful. Our course offers a combination of foundational and theoretical skills. You will learn the mathematical properties of algorithms, but you will also learn a number of practical skills that will allow you to take that theoretical knowledge and then put it into practice. The main objective of this course and the main objective that we have at the Faculty of Information Technology is to give you the skills to create the technology of the future and give you the skills that you need to deal with that dynamic landscape that is technology, right? So technology, it evolves really fast, and so part of what you're learning here is to deal with that pace of change, and a big part of that is to learn to think analytically and creatively. The 4-year version of the course will basically give you a chance to do independent research for a year. So research means that you're trying to answer a question that no one has answered before. And because of the nature of the process, it will imply a great degree of self-learning. You will be supervised by one of the academics in the faculty. And at the beginning, you start kind of being like a student, being given some reference material to read. But by the end of the year, you've actually gained knowledge in an important area of computer science, something that we are trying to understand together. And so I think you start being more like a colleague, because you're working together to answer this important question that has not been answered before. And so if you want to actually produce technology that is very innovative, be at the cutting edge of developing that technology, then the skills that you get by doing this extra year of independent research are going to be really important. I think Monash is a great place, and we have a degree that it's a very good balance of research-led education as well as practical skills that are very useful in the industry. We have a breadth of expertise that is, I think, unparalleled in Australia, and that means that you can explore very different aspects of the discipline of computer science. We also have strong links with industry that will allow you to cap your course with an industry-based project that will allow you to take those skills and actually apply them in the real world. Alternatively, we have the industry-based learning program that will allow you to go and explore in an actual workplace how to put all of those skills that you've learned with us to practice. We have very diverse career paths, and you could, for example, become a data scientist, working in industry to understand big volumes of data and to innovate on the basis of that data. You could also be an advanced programmer or a software engineer that is basically coming up with new algorithms to solve real problems in the real world. People that maybe take an interest in being an entrepreneur. And I think that's an excellent career path as well, perhaps by trying to foresee the future and sort of create those products that will help us improve our lives. And so I believe this is really a great place for you to spend those formative years.